Okay, so don't forget that you do have your test 3 coming up. Don't forget to watch that video, right? We have a video that's posted. It's on Blackboard. The link is on our Blackboard page. It's also in an email I sent you where we go through those other 2 sections. So now we're on homework 3, section 8.1. And we are solving equations using the square root method. Okay, here's the deal. So first of all, you know what a quadratic equation is. I know you have heard that before. So a quadratic equation, or a quadratic, it's a polynomial whose highest exponent is 2. All right, well, that's easy enough. So, you know, it looks like this. This is what the little trinomials that we've been factoring, right? You know your A, you know your B, you know your C. And we have 3 methods to solve them in this class. So you can factor them if they're factorable. We know they're not always factorable, right? If they're prime, we can't solve them by factoring. We have to have a different method. But we've done this method. Okay, now we're going to do the square root method. Super easy and fast. And then when all else fails, we have the big boy, the quadratic formula, which is also very easy. It's just time consuming, right? So we're going to make sure you know how to do all 3. On the test, you're going to have some problems that say, solve. You can solve them any way your little heart desires. Just get me the right answer. But you're also going to have problems that say, solve using square root method. If you solve it another way, even if you get the right answer, I have to mark it wrong. There will be problems where you have to solve it using the correct method. So be really, really okay with that, okay? All right, so the square root property, in that case, okay, what we do, this is really strange. I don't know why they define it like this, but I kind of had to put it in there because they did. I'm gonna get my little cheat sheet packet here. But they're just showing you that when you take the square root of something that's been squared, you get 2 answers. So when I take the square root of a squared letter, a squared variable, I get a plus and a minus as my answer. Okay, that's really important. When you take a square root of a squared term, that's the important part, the squared term, you get a positive and a negative answer. So why is that? Well, think about that. Positive 5 squared is 25. Negative 5 squared, negative 5 times negative 5, is also 25. So that's why when an x squared is involved, you have to give the positive and the negative answer, okay? So that also gives us 2 answers, because remember, if our highest exponent is 2, we need 2 answers. So that gives you the plus and the negative version. You get your 2 answers. Okay, so what this is saying is, if this is your problem, it says use the square root property to solve, all you're going to do is take the square root of both sides. You're going to get an x on the left. You're not just going to get a 4 on the right. You're going to get a plus 4 and a negative 4. You're going to have 2 answers, because if you plug in a positive 4 here, 4 times 4, it checks out. If you plug in a negative 4 here, negative 4 times negative 4, it also checks out. So when you have a squared letter, you have 2 answers, okay? You can write it just like this. I always write it like that because I'm lazy. Or you can actually, you know, write a 4, and then you can write a negative 4, or you can write, you know, with a comma in between. It doesn't matter, whatever you want to do. There's actually a button like this on my math lab. If you click more on a little toolbar, you'll see this pop up. You can just click that and put a 4 and it'll take it. Okay. All right, so look at what I was missing here. I had a squared term and I had a constant term. Who was missing out of my quadratic equation? Yeah, the b, the regular old x, right? So you can only use the square root method if there is no middle term, or no x term. Okay, that's the only time you can use it. So it's kind of specific to the problem, but we'll tell you when you can use it. All right, here are your steps. We're going to isolate. You need to get your squared term all by itself. Take the square root of each side. Some students get confused about which side to put the plus and minus on. You're going to put it on the number side, the side opposite of what was originally squared. Okay. And then if you need to, you can split into two equations and solve both. Here we didn't have to split it into two equations because we'd already solved for x, so we were good. Okay. All right, here we go. Let's just do some quick examples. There's not many, and then I want to give us lots of time for quadratic formula. I ran out of time with my other class yesterday. Okay, this says use the square root property to solve. So here's what you're not going to do. You're not going to look at this and say, oh, there's two of those. I'm going to write 2 and FOIL it out. I'm going to combine the other term. I'm going to get a nice little trinomial and solve it from there. Nope, that's totally legit math, and I'm really proud of you if you did that, but you have to follow the directions, and they say square root method. So sometimes your squared term is as simple as an x squared. Sometimes it's a binomial squared. So I do have a squared term. He's isolated, he's all by himself. So I'm going to jump right in and I'm going to take the square root of each side. Okay, my squared term just happened to be a binomial, but he's still a squared term. When I take the square root of a squared term, it gets super easy and goes down to x plus 6. Okay. Over here, I have the square root of 25. Now, normally you just put 5 and move along, but you had a letter squared on the other side. So instead of just putting a 5, what are you going to write? Plus and minus 5. Okay. So again, I know the square root of 25 is just 5, but you have a squared term on the other side of the equal sign. That's why you have to put both. Okay. Now we're not done. I can't circle this and move on like I did up here. Up here, I got to stop because I had x equals. Here, I'm not done. Okay, so now I'm going to have to split it into two equations. I'm going to have one equation equaling the positive 5, and I'm going to have one equation equaling the negative 5. And then I'm going to solve them and get my two answers. So if I subtract 6 from the positive 5, I get negative 1. If I subtract 6 from the negative 5, I get negative 11. Those are my two answers. Okay, and you can check them both by plugging them back into the original here. Okay, if I put a negative 1 in here, negative 1 plus 6 is 5. 5 squared, that checks out. Negative 11 plus 6 is negative 5, but negative 5 squared is 25. So they both check out. Okay, make sure you have two answers and make sure you know when to split them and when to leave them alone. And it just depends on what's on that left side. Okay, does that make sense? All right, last page. There's only just a few of these examples. Okay, because there's just not a lot to do with this. I mean, it is what it is. Okay, top of page 25 says use the square root property to solve. Okay, here we go. I notice my squared term is just a letter. Fantastic, that's easy. I have to isolate it, so I'm going to subtract 196 from both sides, and I get x squared equals negative 196. Okay. Now, normally, right, I have to be really careful when I'm taking a square root of a negative, but I can do this. I can do it. In fact, I'm going to have two answers because I have a squared letter over here. So how do I handle the square root of a negative? What comes out? I. Okay, good. If you don't need this middle step, you don't have to do it. I forgot my plus and minus. Good gracious, put your plus and minus in. Square root of 196 is 14. And there's your two answers. okay? It ends up being positive 14i and negative 14i. Those are your two answers. How did I know to pull out an I? Because I had a negative under a square root. So you immediately pull out an I and then square root whatever's left. And don't forget you have two answers. Now, why don't I have to split these into two equations and keep going? There's nothing to keep going with, right? Because there's just an X. On the left, there's nothing else. Okay. All right, let's try it again down here. Okay, this is my squared term this side. This time it says square root property. He's isolated, he's all by himself. So I'm going to take the square root of both sides. I'm going to get a nice little 7x minus 5 on the left. All right, I'm going to take the square root of negative 9. What happens to the negative? He's an I. He comes out. So I'm going to have plus or minus I. Okay, and then what's the square root of 9? 3. Okay, is everybody comfortable with that? Square root of negative 9. The negative comes out as an I. Square root of 9 is a 3. Okay, am I done? Can I circle this and move on? No, you don't equal x. So now I have to split up. I'm going to have a 7x minus 5 equals 3i. And a 7x minus 5 equals negative 3i. Okay, so I'm going to add 5. Now be careful here. I have 7x equals, you know you can't combine those two. They are not like terms. I do not want to see anyone here put an 8i, right? Do I write 3i plus 5 or do I write 5 plus 3i? 5 plus 3i, how do you know that? Because remember the form of complex numbers. Your I has to go in the back, right? Remember Ms. Holcomb's faculty meetings? Stick the I in the back. Okay, so we're going to have 5 plus 3i. All right, I'm going to add 5 over here. I get 7x equals 5 minus 3i. Okay, I'm still not done. I'm going to divide by 7. And I get x equals, now, they like two separate terms here for a complex number. They don't like you to leave it as a chunk because there's an I. I think my math lab will accept it, but you really need to split it up because there's an I. Okay. Now, if you forget on your test, I'm not going to mark you wrong. But just know that when an I is involved, you really, really should have two parts. Okay. All right. Is that okay? Everybody good so far? Okay, y'all aren't saying much. I hope you're finding this okay. All right, one more, and then we have good old Pythagorean down there again. Okay, use the square root property to solve. There's my squared term. He's not isolated. Can I just start taking square root of both sides? No. Let's subtract 32. I get 8 plus x, that whole thing is squared, and there's a negative 32. Okay, now that I'm isolated, I'm going to take the square root of both sides. I'm going to get x plus 8 on the left. I'm going to get a plus and minus on the right. I know I'm going to have an I because there's a negative under there. But is the square root of 32 perfect, a perfect square? No. So maybe some of you already know how to reduce that. Otherwise, since it's not perfect, we're going to factor tree, right? 8 times 4. Let's see, that's a 4 and a 2. 4 goes to 2 and 2. Okay, that's a whole lot of 2's. All right, there we go. We broke it down. Okay, my index is 2, so I'm looking to circle groups of 2 numbers. So here's a group. Here's a group. Okay, if I pull this 2 out, if I pull this 2 out, who's left under the radical? That little guy in the back. So the square root of 32 is actually 4 root of 2. Let me just, here's a little public service announcement. On the last test, and I'm going to combine you guys with my other class when I'm talking about students, I mean you guys and them. Half of you wrote this, if I told you to take the square root. The other half of you wrote this. You wrote the wrong number. You got confused about who comes out and who stays in. You did the factor tree perfectly, you circled the groups, but you got confused about where the numbers go. Remember this, radicals are for leftovers. Leftovers only. He's a leftover. He's the one that stays under it. Everybody else comes out. So here's my 4 that came out and my 2 that stayed under. Okay. Does that make sense? We did plus or minus. We pulled out an I. We took the square root of 32. We got 4 root of 2. Are we done? No. Now we have to subtract 8. Okay, now you know you can't combine these two terms because they're different terms. And I know it looks weird, but remember the I goes in the back. So you're going to have a negative 8 plus or minus 4I root of 2. That's your answer. Now, if you wanted to split that up, you could have negative 8 plus 4I root of 2 and negative 8 minus 4I root of 2. These are your actual 2 answers. These are the real 2 answers. This is just me being lazy. This is how a lot of people in math write it. So this is perfectly fine, but this is what they actually are if you'd rather write that, okay? Is everybody okay with that? That's really strange. You're getting into some real deal math answers now. Okay, that's college algebra all day, those ugly answers. All right. Last problem, we're back to good old Pythagoras. We don't even have the picture. I mean the paragraph. All we have is a picture now. Wants us to solve for the length of the cable. So I'm guessing it's the same problem with the electrician and the box and all that. It's just been turned around. So here's our tower. Here's the length. Here's your little box over here, your little transmission box. You're trying to find this. So anybody remember the Pythagorean theorem? Perfect. A squared plus b squared equals c squared. You are going to have to know that for the test. You're going to have to know that. All right. Remember the 2 sides that make the right angle, that's A and B. And it doesn't matter which one you label. So I'm just going to call him A and him B, but it really doesn't matter. You could do it the other way. But here's what does matter. You have to call the diagonal C. You have to. The diagonal that's across from that right angle, he has to be C. You don't have a choice, okay? All right, so now I'm going to have 60 squared plus 32 squared equals C squared. All right, if I square these guys, I've got 3,600 plus 1024, that equals C squared. I'm going to add them together. I get 4624 equals C squared. Am I done? Is that my answer? No, because you have to take the square root. Now let's think about this. The reason we're doing Pythagorean again is because I told you before, when you take the square root of a squared letter, you actually get 2 answers every single time. So when I take the square root of 4624 and I have C squared over here, I'm actually supposed to get plus or minus 68, but I don't use the minus with Pythagorean theorem. I only use the plus. Why? Why do we not use the minus with Pythagorean? Think about what that represents. That's the length of the cable. Would you ever tell someone, cut me negative 68 lengths of something, right? In Pythagorean, what you're actually finding is a length. That's what Pythagorean is. Those numbers are lengths. And you cannot have a negative length. It just doesn't make sense. So that's why we don't ever use a negative with Pythagorean. But I want you to know you're supposed to. It's just he doesn't make sense to use it in his situation. Okay. All right. Sound good? You could put little feet on there, 68 feet. You know, I ran out of room. Okay, let's talk quadratic. Here we go. Last section, solve by quadratic formula. All right, here's your quadratic. So x equals, so we're solving for x. Remember, your standard form of a quadratic looks like this, right? That's your standard form. And so one of the reasons I like to make a really big deal out of A, B, and C when we're factoring is not only because it helps a lot of students factor, but because now you're all ready for quadratic. You're so used to finding A, B, and C that it doesn't intimidate you when we have to find it and plug it in here. So you're going to take the opposite of whatever this number is. If this number is negative, you're going to put in positive. If this number is positive, you're going to put in negative. It's the opposite of whatever B is. You got a plus or minus. Why do we have a plus or minus in something? Because you get two answers that way. And look, how many answers do we want? Two. So that's how we get two answers. Okay. Then you have a square root with some stuff in it. This stuff inside, if a student is going to make a mistake on quadratic, this is where they make it, this stuff in here. That stuff is called the discriminant. That's the part that trips students up. So you're going to square B. This is always going to be a positive number in the front. Minus 4 times A times C. Now, if A or C are negative, minus a negative, you're going to be adding stuff together. So keep that in mind. That happens. Divided by 2 times A. Sometimes under this root is a nasty number that you really can't take the square root of. You just can reduce. So you do, and you do the best you can. Sometimes under that square root is a negative. What happens if there's a negative under the square root? You're going to get an I. So sometimes you're going to get an I. Whatever this comes out as, if you have done all you can leave it as a chunk. You do not ever, ever, ever have to separate unless you choose to. Okay, so it's not like the complex numbers. All right. Okay, so in this class, you do not have to memorize this. When you come in on test day, it will be on the board for you. When you get to college algebra, you have to know the formula. So it wouldn't hurt you to go ahead and be practicing learning the formula. I know there's a song. There's a really cute little song that you can sing and memorize it. I don't know. I'm not the song kind of girl, but there's one out there. They were singing it in the last class, right? Jemiah was there. They were threatening to sing it anyway. There's all kinds of little things you can help to remember it. So I have a little story, okay, because this is college. So it's a little kind of PG-13 story about a party, okay? So I'm going to tell you my little party story. And then you don't have to memorize it, but it would help if you would start learning it, okay? So here you go. All right, I'm going to write it here on my paper. Okay, so we know it's x equals, right? Okay, so there was this negative boy, and he couldn't decide, couldn't make up his mind, if he wanted to go to a radical party. Okay, back in my day, right? Radical is super cool. Leah's like, oh my God. Okay, radical party. Okay, but he was a square. Okay, that's old people talk for like he was boring. He stayed home and did his my math lab. He didn't go. Okay, and he missed out on meeting 4 amazing chicks. And the whole thing was over at 2 a.m. There's your party. There's your quadratic. Okay. So you had a very negative boy. He couldn't decide if he wanted to go to a radical party, but he was a square and he didn't go. And he missed out on meeting 4 amazing chicks. They were going to help him with his mind math lab. Okay. And it was all over at 2 a.m. Okay. So just kind of whatever it takes, you just start thinking about how you're going to remember that so that you have it. But you are going to get it on the board, okay, when you come in. All right, so before you tell me who's A, B, and C, you need to have your equation in this form. You need to have it equals 0 on one side. Please, please, please do not try to tell me what's A, B, and C when you have stuff on each side, because you don't know. The signs are going to be wrong and it's going to mess you up. So move everybody to one side before you do that. All right. Now, besides messing up the discriminant, the other issue I find with students is that they can't figure out how to reduce. They can't figure out where to stop and how to leave their answer. That seems to be the problem. So we're going to practice that. We're going to take these 6 problems. These are the 6 most common endings to the quadratic formula. So you're just going to have to pretend these are your endings. This is what you've come out with. How do you know when to stop? Some of these can be reduced and some of them you leave alone. So we're going to talk about it. All right, first of all, if you just have, look at this little guy down here, a fraction, one number over a number, you know how to reduce a fraction. You know when you can reduce, you know when you can't. So that one's not so bad. The problem seems to be when you have things like these 4. Remember, make a magic triangle. I know it's stupid, but for whatever reason it works. Usually the dumbest things are what you remember, and then that's how you know if you're done, right? Okay, so here we go. Let's practice. So this guy here, am I done? Should I leave him alone? No. Okay, first of all, look what I have. I got a magic triangle. Every point of my triangle, what can I reduce? What can I divide by? 2. So if I divide every point of my triangle by 2, I'm going to get -2 plus or minus 1. There's a 1 back there. It doesn't completely disappear. All over 1. Now, I don't need the denominator there, right? If your denominator is a 1, you can get rid of it. All right. Now, here's another hard part for students. They want to circle that and call it a day. Am I done here? No, because I can keep going. The only time you're going to stop at that point is if you have a radical or an I, 2 terms that cannot combine. Here, I can keep going. I've got a -2 plus 1, and I have a -2 minus 1. I can get 2 really nice answers there. I can get a -1, and I can get a -3. Okay, so not only did I have a triangle to reduce, I then had 2 like terms that I could continue with. Okay, so there are my answers. Okay, let's look at this guy over here. The only difference now is this number over here is under a radical. Are you allowed to go in a radical and start messing around? No, you can reduce if possible, but can you reduce the square root of 2? No. So is there anything I can do with this guy? No, you don't have a magic triangle. So you're done. You're done. Okay. There's nothing you can do. You do not have a magic triangle because this number is under a radical. Okay, compare it to this guy. Now I still have a radical, but look what I have out in front of the radical. Now I got a number. Now I have a magic triangle. I got a triangle now. I did not have one here, but now I do. So if I divide every little part, every little peak by 2, I get -2 plus or minus root of 3. Denominator's 1, so I don't have to worry about him. Okay, now up here at this point, I had to keep going. Can I keep going down here or am I done? I'm done. Because these are not like terms. These were like terms up here. But at this point, I have to stop because I cannot combine them. So magic triangle is your first question. Can you do a triangle? If you can do it, then ask yourself, are those like terms? If they are, you keep going. If they're not, you're done. Okay, over here. First question I'm going to ask, is there a magic triangle? There's not. I'm done. Okay, so magic triangle, yes or no? Like terms, yes or no? Okay, down here, I don't have a denominator up here, so I can't do a triangle. Are these like terms? I'm done. Okay. All right, over here, I just have a fraction, so there's no way for me to get a triangle, but I have to look and see. Right here, I'm trying to tempt you to tell me that these 2 can cancel. Can these 2 cancel? No, because you can't go in there, so that's done. The only thing you could do is if you had a situation like this. In this case, okay, now these 2 can divide, right? A 4 divided by a 2 is a 2 root of 2. That would be your answer, okay? So I just kind of want you to keep these in mind. That seems to be the hardest part for students. Okay, let's do some examples then and jump right in and do these and see how far we can go. Okay, everybody all right? Good? Okay. All right, so let's look at this guy. Can I jump right in and do ABC? No, I got to move everybody to one side. Now you could move these two to the other side and all that, but the fastest thing to me would be to add 2y. So if I add 2y to the other side, that's what I get. Yes, go ahead. I thought you might, but I wasn't sure what y'all were talking about. This guy here? Okay, good. Okay, so there is another option. Kirsten, there is another option. You can split this up like this. You can split it. And then this is going to become -2 plus or minus root of 3 over 2. But that's just a lot of work. Here, the only way that you could simplify it is if you had some coefficient out front. You have to make a triangle. You have to, because every single term has to have something in common, not just two terms. So that's the issue there. I can't just divide these unless I broke it into two separate terms. So you could do that if it bothers you. You could separate it like this. Right here? Oh, okay. So over here. Oh, I gotcha. I see what you're talking about. There's not a plus or minus here. That's why. Sorry. Okay, sometimes I don't understand the question. Yeah, that's the only reason why I was able to reduce here. That's a good question. Because there's not a plus or minus. Yeah. Okay. All right, so we moved everybody to one side. All right, if this bothers you, you can always make this equal 0. You know, you can move that around, but there we go. Okay, so we have an A is 3, a B is 2, and a C is -8. All right, we're going to throw it right in. So we're going to have an X equals, this is the opposite of B, or -B. So if my B is 2, what am I going to put? -2. Plus or minus, that's going to give me two answers. Here's my radical. B squared, so 2 squared is 4, minus the number 4 times A times C, all over 2 times A. Okay, put them all in there. Okay, now I'm going to kind of move up here so I have a little more room. Okay, everybody good so far with what we did? Okay, I'm going to do -2 plus or minus, put in my radical. Okay, now if you're ready to jump right in and give me the entire number under that radical, you go right ahead. I'm going to take it just 2 steps, so I'm going to take it a little slow this time and then I'll speed it up on the next ones. But I'm going to have 4 minus, and then 4 times 3 times -8 gives me a -96 all over 6. Some of you probably jumped right ahead and got a 100 underneath that radical. That's fine. Make sure you realize this is where students mess up. This first term, this B squared, is always positive. You should never, ever, ever have a negative number here. Then if you have minus a negative, you're going to be adding 4 plus 96, you get 100. So be careful at that point. Okay, here we go. I can reduce that radical. What's the square root of 100? 10. Okay, next question I ask is, do I have a triangle? Sure I do. Okay, what can I divide every little piece by? 2. I get x equals -1 plus or minus 5 over 3. Okay, am I done or can I keep going? I can keep going, right? There's nothing stopping me because these are all like terms. So I'm going to keep going. Here I go. I'm going to go over here. So I'm going to have x equals -1 plus 5 over 3. And I'm going to have an x equals a -1 minus 5 over 3. I have two answers. I just split up that plus and minus. Remember, you have to have two answers, and there's nothing stopping me from keeping going. So here, -1 plus 5 is 4, divided by 3, that's as good as it gets. Here, -1 minus 5, it's a -6, divided by 3, I get a nice little -2 for him. So those are your two answers. I did triangle. I realized they were like terms, I could keep going, so I split it up and kept going. If at this point I had a radical or an I would have stopped and circled it because they would not have been like terms. Okay. All right, let's try another one. Okay, here we go. All right, am I ready to jump in and do A, B, and C on him? Yeah, here we go. All right, what's my A gonna be? 1, good. B is 6, C is 25. Okay, so I have X equals opposite of B or negative B, it's a -6, plus or minus, here's your radical, B squared, that's a 36, minus 4 times A times C, all over 2A. Okay. All right, let's clean it up a little bit. Let's look inside this radical for a minute. So I'm just going to kind of write it up above here. I'm going to have a 36 minus, so 4 times 1 times 25, that's a 100. 36 minus 100 gives me -64, all over 2. Okay. Looks like an equals, but that's a minus. All right, everybody okay with what happened in that, under that radical? All right, I have a negative under there. What am I going to have in my answer? I. Be prepared, you're going to have an I. Okay, here we go. -6 plus or minus. We already said since we have a negative, we're going to have an I. What's the square root of 64? 8 over 2. Okay, question I'm going to ask, do I have a triangle? Yep, you bet I do. I have a nice little triangle. Okay, I can divide everybody at the little vertex there of 2. I'm going to have -3 plus or minus 4i, and I don't need the 1 in the bottom. Can I combine these? Nope, I'm done. If you wanted to separate them, there's an answer and there's an answer, but you can always leave it as 1 if you want to. Okay, so we had an I, we handled it. We did a magic triangle. Then we realized that they were not like terms, so we were done. Okay. All right, let's keep going. Let's see, let's try this next one. Okay, am I ready for ABC here? Yeah. We have A is 6, B is -2, C is -5. Okay. X equals, oh, this is interesting. We have a -B. We haven't had one of those. Okay, so I'm supposed to put the opposite of B or -B in the front, but my B is -2. So what am I going to put? 2. Just a +2, right? The opposite of -2 is +2, or -2 is +2. So be real careful with your signs there. Okay, now remember, this first term that goes under here, the squared term, is always positive. So -2 squared is going to be what? +4, right? -2 times -2 minus the number 4 times A times C. And then I just make a mental note in my head that I'm going to be subtracting a negative, which means I'm going to be adding. I better not have a negative discriminant, a negative radicand under there, okay? All over 2A. Okay, let's clean it up a little bit. All right, so if I kind of work on that radical a little bit, I'm going to have 4 minus 4 times 6 times a negative 5 is negative 120. 4 minus a negative 120 means I'm going to have 4 plus 120. So I'm going to have a square root of 124 all over 12. Everybody good so far? Okay. All right, I have 2 plus or minus. Am I going to pull out an I in this situation? No. Remember, you only pull out I's when it's negative. Okay. Is there a nice, pretty square root of 124? No. So that means either you're comfortable figuring out what it is, or we're going to factor tree. Those are your two options. Okay, I'm going to factor tree. So let's see. I'm going to go over here. Let's see, 124. I go in my calculator, I divide it in by 2, I got 62. Okay, so 2's along for the ride. I divided 62 by 2 and I got 31. Well, that ended quickly. I thought it would have gone on farther, but that's actually it. Okay, so you have a square root, so that means groups of 2. So 2 comes out. Who's left under? The 31, because he's the leftover. He's the one that's not part of the group. Okay, so what you're going to have is 2 plus or minus 2 root of 31, all divided by 12. Does that make sense? Everybody see how every little thing we learn in math, we end up using. We worked forever on radicals. We had a whole unit on it. Boy, we are using them like crazy now, right? So everything we do, we're kind of building on it. All right, am I done, or do I need to look for a triangle? I got a triangle. I got a triangle. Okay, everybody gets divided by 2. I get 1 plus or minus root of 31, because I don't need a 1 out in front of them, all over 6. Okay, can I go any further? Are there like terms at all? No, I'm good to go. Okay, that's my, or you could, split it into 2 answers if you really wanted to. 1 plus root of 31 over 6, 1 minus root of 31 over 6. Okay, let's look. This next guy is super weird. He's meant to be easy, but he freaks students out, so let's talk about him. Okay, we're supposed to be doing the same thing. We're ready for ABC. We're all on one side. And we're supposed to be using quadratic formula here, because that's the section we're in. Normally it would tell you to use quadratic formula. Okay, so what's my A? 5. That's easy enough. And I'm sure that you guys know your C is 2. Your B, though, he's supposed to be with the X term. What's my B going to be? It's 0. H3 said 0. Yeah, because there isn't one. That's okay. That's a legitimate number. So here we go. X equals. Okay, I'm supposed to have the opposite of B. What am I going to put there? 0. Or you can just ignore it and put plus or minus, because it really doesn't matter. Square root. Okay, I'm supposed to square B now. Still 0. Or you can put, leave it alone, minus 4 times A times C, all over 2A. This is how you end up with that little fractional answer that we had at the bottom, where you don't have the 3 pieces, the 3 parts of the triangle. Okay, here we go. Negative 4 times 5 times 2, I get a negative 40. I make a little note, I'm going to have an I in my answer. Why do I have an I in my answer? It's negative. Yeah. Okay, here we go. Still have plus or minus. That's the only way you get 2 answers. All right, I'm going to pull out an I, and now I have square root of 40. Well, he's not perfect. Okay, I think I might have room to factor tree him. Let's see. 4 and 10 breaks me down to that. 3 2s and a 5. Okay, I'm looking for groups of 2. There's one. I'm going to pull it out. What's going to be left under my radical? 10, a 2 and a 5. Multiply them together. That's what I end up with. So I'm going to have 2i root of 10. Make sure you squeeze that I in there between the 2 and the root. And then I have a nice little 10 on the bottom. Okay, now I don't have a triangle, but you guys know any fraction you have can be reduced, the top and the bottom, as long as you don't go inside the radical. So when I see this, what I'm looking at are these two numbers here. That can be reduced. I can divide both of those by 2, and I'm going to get plus or minus I root of 10 over 5. I'm just dividing that top and bottom by 2. That's a super weird answer, but it's an answer, you know. So like I said, it seems like the formula itself isn't bad. It seems like the problem tends to be the answers. Okay. All right, let's do, I think you're going to be okay with this top one. I'm going to let you do it because I want to do the fractional ones down at the bottom. Remember, this is under content on Blackboard. It's got the whole thing worked out. Or if you're too lazy to do that, I don't blame you. You can always come and just take a picture of mine before you leave if you want it. But I will go ahead and tell you that the answers, you're going to come out with a situation where you have a perfect square root, and then you keep going. You do your triangle. No, I don't think you can do a triangle here. But you take the square root, and then everything's a like term. So you just keep going, and you end up with 2 really nice answers. Okay, but you can just take a screenshot of my notes if you want to, or you can look it up on Blackboard. But I want to be able to do some fraction ones with you. Okay, so here we go. Everybody got those 2 answers before I move it up? Good, okay. All right, so remember, don't let these throw you off your game. It's still just fractional exponents. So we want to get rid of them. We want to get rid of the denominators, and we have an equal sign, which is great because we can get rid of the denominators. Remember, this little guy is actually over 1, so everybody has a denominator. What's my LCD going to be? 3, right? Every denominator can go into a 3. So if I multiply all the tops by 3, okay, what happens to these bottoms here? They're going to cancel, right? Now you can cancel them right from the get-go if you want to, or you can do what I'm doing and just add in another step. It's up to you. If you just want to go ahead and cancel them from here, you can. But what you're going to end up with is x squared minus 3x equals 1. That's what you're going to end up with. Now, can I go ahead and do ABC? No, I'm not all on the same side. I got to move that 1 over. So I'm going to subtract that 1 and get that. Okay. Now my A is 1, my B is -3, my C is -1. Now I'm going to plug them in. So x equals opposite of B. My B is -3, so I'm going to just write 3 plus or minus radical -3 squared, nice little positive 9, minus the number 4, A times C, all over 2 times A. Let me tell you another common thing I see. I have students that are fantastic at quadratic formula, but you know what they do? They only put the fraction bar under the radical. They think this is the only part that is over 2A. It's not. It's the whole shebang is over 2A, right? The whole party gets over at 2 a.m. So it's the whole thing. Okay, let's clean it up. 3 plus or minus. Okay, if I start messing around under the radical, I'm going to have 9 minus 4 times 1 is 4 times a -1, that's -4. 9 minus a -4, square root of 13, all over 2. Okay, do I have a magic triangle? No, and I didn't even ask, can I reduce 13, square root of 13? No. Okay, you're done. Okay, last one. We're going to weasel it in here real quick. Okay, Got a bunch of fractions. I'm all on the same side. What's my LCD going to be? Nice little 7, huh? They all have a denominator of 7. We're going to multiply them all by 7. Okay. You can go ahead and do it right from the get-go if you want. Now let me tell you about this. Notice that, look at this problem up here. This is how you're used to seeing it. You had your letters in the numerator. Suddenly they start writing the letters next to it on the side. These are exactly the same thing. If this bothers you, you just put those Y's right in the top. You don't have to put them out to the side. Both ways to write it are correct, and it just depends on your math book. So sometimes I like to give you both so that if you see it later, you don't freak out. Okay, I'm going to reduce and get 2y squared plus 3y plus 2. Okay. My A is 2, my B is 3, and my C is 2. All right, I'm going to let you plug it in, but I'm just going to tell you that what you end up with is this. Okay, I'm going to go ahead and let you plug it all in. But am I done at this point? Because I don't have a magic triangle and they're not like terms. Can I leave it, or do you see something in there that I ought to handle? That negative, I need to pull out an I. Good. You need to pull out that I and leave it as the root of positive 7. Don't forget to do that. Now you're done. You can't reduce root of 7. You don't have a magic triangle. You don't have like terms. Now you're done. Okay? So I'm going to email you guys this link in case you want it. But otherwise, Monday, I will see you, and I will be sure and have your donuts and everything. Okay, I'm supposed to do class counts again. Hold on. Is it just gold today, or what's the?
It's gold.
Everybody gold?
Yeah.
Okay, you got a jacket on. You're gold. Okay. Rhiannon, you're gold. You're in what grade are you in? Junior? Okay. All right. You've got a jacket on. I'm taking it, Shalandra. Are you junior or senior?
Junior.
Junior. Okay, Brady's gold. Nice. Okay. Oh, your hair's pretty. Okay. All right. You guys got anything gold on back there? Okay. Just trying to help.